Okay, so rational exponents. Rational exponents just means that we've been working with the radicals for this whole entire lesson, but you can actually change the radical to be in exponential form, which would be the base or the radicand, to a fractional power. A radical transforms into a fractional power. So in this case, if you have a to the 1 over n power, that's just the nth root of a. If you have a to the m over n, then that's n roots of a over n. The denominator of your fraction is your index, and then the numerator is whatever the power the radicand has, and the base of your exponential form is your radical. So let's look at these first three examples. On these first two examples, what we're going to be doing is we're going to rewrite each of them in radical form. So we're just going to go from exponential to radical. In this case right here, we have k to the 7/2. Your denominator is your base. So first things first is you need a radical sign. Your base goes in your little pedestal. And since it is the square root of 2, remember we don't always write 2 as our index for square root. You could leave that off. And then inside we would have k, and the numerator is just the power. And from here you would simplify if needed. Notice that 2 that you can have not 3, we're in square roots. So you can break up k to the 7th as k to the 6th and k to the 1st, because 7 is not a multiple of 2, but 6 is the biggest multiple of 2 that's less than 7. And from here, you can split that up as k to the 6th times k to the 1st. And then to take the square root, remember you just take the exponent and divide it by the index. We have an index of 2, so 6 divided by 2, and then the square root of k, and then this would be it. So let's say you have more than one thing underneath the square root, like more than one thing in parentheses. Everything in parentheses, that means this is your radicand. So when you go to do your radical sign, remember to do your radical sign. The denominator is your base, or the denominator is your index. The base right here of the exponential is your radicand. And notice that you have a numerator of 3. A and B are being raised to the 3rd power. And having A and B to the 3rd power, you could distribute the 3 back over as A cubed, B cubed. And then you check, can you simplify these? And in this case, you can't, because these exponents are smaller than the index, so we can't even break this up. So this would be your answer. Now then, this third example is actually changing the radical to be exponential. So we're going to go from here to here. And then first things first, find your base. Your radicand is your base. And this is going to be to a fractional power. Your index is your denominator. And if it has a power right here, that's your numerator. If not, then it's just the numerator. And then this would be it. That's all you do for that one, is you're just rewriting it. On these next two examples, we're going to be, so you can simplify with radicals in exponential form. To simplify them, you just rewrite into exponential form. So first things first, you want them all in exponential form. This first example is already in exponential form with us, but the second one is not, so we will need to change them to exponential form first. Secondly, we're going to use our exponents rule. It should be just exponent rules to simplify. Simplify. And then we're going to rewrite as a radical. And lastly, you'll just simplify. Simplify your radical as much as you're possible. So looking at example 4, these are already in exponential form, so now we just follow the exponent rules. The exponent rule states that if you have a variable to a power raised to another power, you're going to multiply. So to multiply fractions, remember it's just numerator times numerator, denominator times denominator. So this becomes 32 to the 1/4. Now that we've used the exponent rules to simplify, we're going to rewrite as a radical. So we're going to need our radical sign. Our base is our radicand. It's a power of 1, so you could write the 1 or you can't. And then it's an index of 4. And in this case, you would simplify. And we can simplify because the perfect fourths go 1/16 unit 1. 16 is actually half of 32. Fourth root of 16 times the fourth root of 2. And 16 is 2 to the 4th power. So C comes 2 fourth roots of 2. And that would be your answer. Now then, let's look at example 5. So when we rewrite them, your radicand is now your base. Your index is your denominator. And if there's a power, that's your numerator. Times r. It has an exponent of 1, so the numerator is 1, and this is 2. And remember, when we multiply variables, we add their exponents. But since they're fractions, to add fractions, you need a common denominator. And in this case, you're going to have to multiply the second one by 2 over 2. This gives you r to the 3/4 times r to the 2/4. And now that they have a common denominator, you can add. So you just add the numerators, 3 plus 2, which is 5, and you keep the denominator the same. Now we rewrite it as one radical. We still have a radicand of r. 4 is our index, and 5 just says we have the 5th power. And from here, you would simplify. So you ask yourself, 5 is not, you ask yourself, is 5 a power? Not a power, a multiple of 4. In this case, it is not, but 4 r to the 5th can be broken down into r to the 4th times r to the 1, because 4 goes into 5. There's a 4, there's 4 is less than 5. And from here, you go 4th root of r to the 4th times the 4th root of r. And remember, when you take the root of a variable with an exponent, you just divide. 4 divided by 4 is 1. 4th root of r stays the same. And you don't have to write the 1. You could just leave it as r. And then this would be your answer. And voila. So most of this is just rewrite them in the different forms to get used to it, and then rewrite them all in exponential form to do these kind of problems. Rewrite them in exponential form, perform whatever needs to be performed. In this case, we raised to a power. In this case, we multiplied, and then simplify, change it back into a radical, and simplify where needed.